All right, so today we're going to turn our attention to volume. We've been talking about surface area. So we're going to find the volume of prisms, pyramids, cylinders, and cones. Okay. So some vocabulary for you first. The volume of a solid is determined by the number of cubic units contained in the interior. In other words, if we wanted to slide 1 by 1 by 1 sized cubes into a space, it's how many 1 by 1 by 1 sized cubes we'd fit in, right? So this is 1, 1, all these edge lengths are 1. So if there are 4 cubes high, 2 cubes across, and 2 cubes deep in this space, then the volume would just be counting up those cubes, right? There's 1, 2, 3, 4, 5, 6, 7, 8, and then 8 more behind, and so the volume of this prism would be 16 cubic units. Can't see that very well, my pen got stuck, but 16 cubic units. Okay? That's sort of the technical definition of volume. Now, there is an easier way to find that, and we'll discuss that in just a second. Some postulates. Okay? The volume of a cube is simply taking the edge length and cubing it, right? We go S times S times S, because all these are S's, and we get S cubed, okay? Now, a couple of other postulates that are just incredibly obvious. If 2 polyhedra are congruent, then they have the same volume, if that makes sense. And then volume addition is useful. It says that if you have a solid that you don't have a formula for or a way to find the volume as a whole, you can always cut it up into parts and just add those parts up, and that'll be the volume of the whole solid, which makes sense. Okay, for example, this guy. To find the volume of this guy, we'd want to go find the volume of this prism first, right, which is 7 cubes this way, 2 cubes back. So you're going to have 2 rows of 7 cubes. That's going to be 14 cubes overall. And then we can find the volume of this thing, which is 2 cubes deep and 2 cubes high. So you're going to have, and then 1 cube across. So you're basically going to have, right, 1, 2, 3, 4. 4 cubes there. And then the left-hand side, right, we're going to have 2 cubes high. Oh, hang on a minute. Let's go back and do this 4 again. Look at this 4 again. Just this prism right here, right, is only 1 cube high, 1 cube across, but 2 cubes deep. So there's going to be 2 cubes in here. And if we divide this space up for the left-hand side, right, then we would go like this, and you'd have 4 cubes in here. So 14 plus 2 plus 4 is going to be 20 units, 20 cubic units. Okay? Now, like I said before, there's an easier way to find volume than counting up these cubes. And the problem is sometimes you can't fit a whole 1 by 1 by 1 cube in a space. Sometimes you need part of it. And so we have to find a better way to find volume. And there are better ways, and those ways are this, right? The volume of a prism, and I kind of think about this as pouring water into how much water it takes to fill it up. So in a prism, I'm going to pour water in, and when I pour water in, I'm going to cover this base first. So I need to find the area of the base. That'll tell me how much water I need to cover just to cover the base, just like covering it with paper. And then I'm going to fill this up. And the way I make that water level rise is to multiply it by H. So the volume formula just turns into the area of the base times the height of the prism. That's it. The only thing we got to do now is realize what shape the base is in and be able to find the area of it. Same thing for a cylinder. If I'm going to pour water into this cylinder, I've got to cover the base first, and the area of the base is a circle. The area of a circle is pi r squared. And then to make the water level rise, I multiply it by the height, and so we end up with pi r squared times h. Okay? Let's put those to use. Here's a right trapezoidal prism. And to find the volume, I got to find the area of the base times the height of the prism. Now, the height of the prism is the distance between the two bases, and that's this right here. So it's 5. The area of the base, and it's useful to kind of pull this off to the side. Now I have to turn my attention to just the base. The base shape is just this trapezoid. And the area formula is 1/2 times the height times adding the bases of the trapezoid up. So you can kind of see why it's useful to separate these concepts. Because the trapezoid has two bases. It's 14, and it's going to be this 6, which is the same length as that bottom 6. So we got to do 14 plus 6 here, multiplied by the height of the trapezoid, which is this right here. So 3, and then times 1/2. Well, 14 plus 6 is 20, times 3 is 60, and then 1/2 of that is 30. So the area of that trapezoid is 30. So we simply take 30 times 5, and the volume is 150 centimeters cubed. Okay? Same thing over here. Volume is find the area of the base, multiply it by the height. The base here is a circle. The area of a circle is pi r squared times h. The radius is 9, and the height is 6 for that cylinder. So we go 81 times 6, which is 486 pi. So you can multiply the 486 times pi if you'd like to get a decimal answer. I'm going to leave it like that. Sometimes we work with volume in terms of pi. Okay? So there you go. Now, we can use volume to kind of work our way backwards to some edge measurements if we need to. For example, this guy, the volume of this alarm clock, which is a cube, is 90 cubic inches. Find the value of x. What's a cube? The way we find the volume of a cube is to cube the side, so s to the third. The volume is 90, and the side length is x. So we can cube root both sides, right? That's how we undo the third power, is to take the third root, okay? What that means is we got to find a number that times itself 3 times will give you 90. Well, it doesn't really exist. So we got to punch it into our calculator, and depending on your calculator, the buttons that you push may be a little bit different. So if you're not sure how to use your calculator, make sure that you find me and ask me how to get the cube root out of your calculator. But it should be 4.5, rounded, 4.5. Okay. Excuse me. Now, Cavalieri's principle is the next theorem we're going to talk about. And basically it says that if two shapes have the same height and their cross-section has the same area all the way up and down, then they're going to have the same volume. So in other words, the cross-section of this prism is this rectangle, and the cross-section of this cylinder is this circle. So if this rectangle and this circle have the same area, and these guys have the same height, then they're going to have the same volume, which is useful. It's useful in a situation like this. where we have an oblique cylinder. And if we were to slide a plane sort of at a slant here, then it would create a cross-section that's a circle, and the circle whose radius is 4. Now, this volume would be the same as a right cylinder who has a radius of 4, because its cross-section could also be a circle whose radius is 4. So what that tells us is that we can use the exact same volume formula to find the volume of an oblique cylinder as we used to find a right cylinder. It doesn't work that way with surface area, but it works that way with volume. So all we got to do is find the area of the base times the height. Area of the base is pi r squared, and then the height of the cylinder is 7. So this is going to be 16 times 7, which is going to be 112 pi. And again, I'll leave it in terms of pi. You can always multiply it out to find the decimal answer if you'd like. Okay? But bottom line here is that an oblique cylinder or an oblique cone or an oblique prism or an oblique pyramid, which we're going to talk about in a little bit, will have the same volume as a right one. No slant heights necessary. Okay? Speaking of pyramid and cone, okay, the volume of a pyramid and a cone. Well, the same thought process as a prism or a cylinder. Imagine, if you will, finding the volume of a prism. Okay? Finding a pyramid is just like a prism, where we're going to have to, if we're going to pour water in that pyramid, then we're going to have to cover the base first. So we got to know how much water to cover the base. That's the area of the base. And then the height will tell us how much water, how far up that level has to rise for the water. Now, we can't just leave it at base times height, because that would tell you how much water to fill that prism with. A pyramid comes to a point, comes to a vertex, and so you are going to lose some volume. As a matter of fact, you're going to lose 2/3 of that volume. So the volume of a pyramid is going to be 1/3 of the volume of a prism. So in other words, the formula turns into 1/3 times the area of the base times the height. And for the exact same reason as a cylinder versus a cone, the volume formula turns into 1/3 times pi r squared times h for a cone. Okay? Comparing these volumes to a prism or a cylinder, we need 1/3 of that volume to fill a pyramid and a cone. So we've got, we multiply these same formulas by 1/3, and that's it. That's the only difference. Okay? So let's go find some volumes. For this pyramid, we're going to take 1/3 of the area of the base times the height of the pyramid. Now the area of the base we need to go figure out. The height of the pyramid is 9. The area of a base, now I'm going to pull this off to the side. The base is in the shape of this right triangle. That's what I want to find the area of. The area of a triangle is 1/2 base times height, where the base is 4 and the height is 6. Okay? Now you multiply that out. 1/2 of 4 is 2 times 6 is 12. And so the area of that triangle is just 12. So 1/3 of 12 is 4. 4 times 9 is 36. This is going to be 36 cubic meters. Cone is the same deal. It's 1/3 times the area of the base, which is a circle, which is pi r squared, times the height. So pi times 2.2 squared times the height, which is 4.5. And it doesn't matter that it's oblique, because again, Cavalieri's principle says that it's going to have the same volume as a right one. So we would take 2.2 squared times 4.5, and then divide that by 3, and you get 7.26 times pi. And again, you can multiply that out to find the decimal answer, and sometimes you need to do that. Okay? But I'm going to leave it like that. All right? So just using the formula. Here's when we were working backwards, right? We're talking about the Great Pyramids in Egypt, right? The pyramid had a height of 144 meters and a volume of 2,226,450 cubic meters. Find the side length of the square base. So this is a pyramid whose base is square. That's a pretty rough sketch, the height of which is 144 meters. So the volume is 2,226,450. And to find the volume of a pyramid, we got to take 1/3 times the area of the base times the height. So the area of the base is going to be that square, where we don't know the edge length. So the area of a square is just x squared, and the height is 144. So now we can take 1/3 of 144 and get 48x squared. And that's going to be equal to 2,226,450. Divide that by 48, and you get 46,384.375, and then square root. And so the length of the side length of the square base is going to be 215.4 meters. And since we're in America, we have no idea how long that is. But whatever, there it is. Okay? Now, two more quick examples I want to show you. Right? If we're going to find the volume of this cone, we know we're going to take 1/3 times the area of the base, which is pi r squared, times the height. Now, r, we don't know what the radius is, but the height is 16. But what we realize is that when you draw in the height, the radius, and you take into consideration this slant height, that makes a right triangle. And what we do know is that that height is 16, and the angle that the slant height and the radius make is 65. That means we're going to have to use trig. Trigonometry exists because we need to be able to find side lengths knowing only one side and an angle measure. So from that angle, we know the opposite, and we want to find the adjacent, that is tangent. So tangent of 65 is going to be equal to 16 over r. And to find r, we'd simply take 16 and divide it by the tangent of 65. Okay? And so that radius is going to be 7.46. So again, we're dealing with some right triangles some. So you need to be able and aware and able to use any of our right triangle stuff. So now we'd take 7.46 squared times 16, divide that by 3, and the volume ends up being 296.9 times pi feet cubed. And again, you can multiply that pi out and get your decimal answer if you need to. Okay? Last but not least, if I want to find the volume of this particular solid, okay, our postulate tells us that all we have to do is find the volume of this bottom prism and then add in the volume of this pyramid. The volume of that bottom prism is the area of the base times the height, and then we're going to add in 1/3 of the area of the base of that pyramid times its height. Well, in this bottom prism, The base is in the shape of this square. So the area of that square is just 6 times 6. And the height is 6. We add to that 1/3 times. Now the base of this pyramid is also the square with the same dimensions, 6 times 6. And the height is here is 6 again. So a bunch of 6's. So 6 times 6 times 6 is 216. And then we divide that by 3 to get this back part, 72. And so the volume of this guy is 288 meters cubed. Okay? Simple enough. Volume much easier than surface area, I think. So there you go. Homework's out in Canvas. Make sure you have that done by next time.